So here we're going to take our GCF out. In this case, it's 6. And I'm left with 2x squared plus 5x plus 2. And this is a great example of making intelligent guesses, or a great problem to make this example out of. The options for 2 are simply 2x and x. The options on the back end for 2 are simply 1 and 2. But it makes no sense to put 2 in the first parenthesis, because if I put 2 in the first parenthesis, I have a GCF. So I'm going to put 1 here and 2 here. That's 4x and that's x. 4x and x combined to be 5x. So these would be both plus signs right here. And now, I can these down a little bit. And now I can solve each of these. I set them equal to 0. Whoops. Jumping the gun there. Here we go. 2x plus 1 equals 0, and x plus 2 equals 0. So 2x equals a negative 1, x equals negative 1/2. We subtract 2 on both sides, we get a negative 2. And those are my answers. Notice there's no GCFs in either parenthesis, and my GCF I pulled out. Since there's no variable with it, I don't need to set it equal to 0. You don't set 6 equal to 0. It clearly doesn't equal 0. Okay. Next one, I'm going to take a 3 out, and I'm left with x squared plus 10x plus 25. That's an interesting one in the sense that if you factor it, you put your parentheses down, x and x for the x squared. My factors are 25, or 5 and 5, or 1 and 25. I'm going to use 5 and 5 here. Because 5x and 5x give me my 10x that I need. Okay. Now, since I get the same thing, I'm going to write it as a binomial squared. X plus 5 times x plus 5 is x plus 5 squared. And in this one case, you only need to solve one problem. You only have one answer because negative 5 appears as your answer twice. We would call that a double root. And then my last one, there is no GCF from a number standpoint, but I can pull an x out. And that gives me something I can factor. Right? You're not going to be able to factor 4x cubed minus 33x squared plus 35x. But when I pull the x out, now I'm left with something I can factor. Okay? If I try 2x and 2x, watch what happens. I can put the 5 and 7 anywhere. But I get 14x and 10x. That gives me 24x. That's no good. And 7 and 5 switching them is not going to make any difference. If I try 35 and 1, my other factors are 7. Or my other factors of, 35. I ended up with 70x and 2x. That's no good. So if that doesn't work, well, I have another option for 4x. I could do 4x and x. And now let's try 7 and 5. If I put the 7 here and the 5 here, 28x and 5x, well, those can combine to be a negative 33. Negative 5, negative 7. And now we set the GCF equal to 0, the 4x minus 5 equal to 0, and the x minus 7 equal to 0. X equals 0 is an answer. 4x equals 5, x equals 5/4 is an answer. And then we add 7 to both sides, and x equals 7 is my answer. You're going to be asked to graph them. You're going to be asked to get the absolute value of them. Graphing them, the real number is kind of like your x-coordinate. The imaginary is your y, or the imaginary number's coefficient is your y-coordinate. So 4 plus 5i. 1, 2, 3, 4. 1, 2, 3, 4, 5. And you're going to write the number next to the dot. Negative 2, negative 3i. Negative 2, left 2, down 3. Negative 2, negative 2 minus 3i. 4 minus I, 1, 2, 3, 4, down negative 1. 4 minus I. Now, if I'm going to get the absolute value of them, It's simply this. It's the real number squared plus the coefficient of the imaginary number squared. And we take the square root of that number. 16 plus 25. The absolute value is root 41. If you can simplify it, you do so. If you can't, you leave it. The absolute value of negative 2 minus 3i is negative 2 squared plus negative 3 squared. 4 plus 9, root 13. Finally, the absolute value of 4 minus I, 4 squared plus negative 1 squared. 16 plus 1, my absolute value is root 17. If you can simplify those radicals, you do so. If you can't, you leave it. Simplifying a negative radical. Once again, we're simply breaking it down. Okay? Now, if you want to write it first as this, feel free. Square root of negative 1 times the square root of 18. Square root of negative 1 times the square root of 81. Square root of negative 1 times the square root of 45. And you're breaking down the positive radical. The square root of negative 1, the square root of negative 1 is I. Okay? I can't stress this enough. You need to know that I equals the square root of negative 1. And you also need to know that I squared equals negative 1. We should know those definitions. So breaking down the radical. 2 and 9, 3 and 3. The pair of 3's goes on the outside. The prime number goes on the inside. Since you have a negative 1 under a radical, it's 3i root 2. If it was just root 18, it'd be 3 root 2. This is negative 18, 3i root 2. The square root of 81 is 9. The square root of negative 1 is I. If you have a perfect square, just take it. Here, 2 doesn't go into 45, 3 does. And 3 goes into 15 5 times. So I have a pair of 3's, root 5, but I have that square root of negative 1, so that leaves me with an I. So my answer is 3i root 5. Adding and subtracting complex numbers is pretty basic. For adding, we're combining like terms. 4 and 9 is 13. 6i and negative 3i is 3i. That's the answer. When you're subtracting, my advice is to copy the parenthesis over and distribute the negative. Negative 2 and negative 7 is negative 9. Negative 8i and 2i is negative 6i. And that's our answer. So when we multiply the complex numbers here, we're essentially foiling. 4 times 3, that's 12. 4 times negative 5i, that's negative 20i. 2i times 3, that's 6i. 2i times negative 5i, that's negative 10i squared. Okay? We need to know, as I said earlier, I squared means negative 1. So 12 minus 20i plus 6i, this becomes a positive 10. The I squared in the end goes away. It's replaced by the negative 1. A negative 1 times negative 10 is 10. And now I'm combining my like terms. 12 and 10 is 22. Negative 20i and 6i is negative 14i. And that right there, my friends, is your answer. The second one, negative 7 times 2, negative 14. You do need to be aware of signs at all times. Negative 7 times 3i is negative 21i. 3i times 2 is a positive 6i. 3i times 3i is a positive 9i squared. And that I squared turns into a negative 1, which means 9 times negative 1 is negative 9. Negative 14 and negative 9 is negative 23. Negative 21i and positive 6i is a negative 15i. And there's my answer. When you're rationalizing denominators, when there's just an I in the denominator, you're multiplying the top and the bottom by just I. 2I over 3I squared, which is 2I over a negative 3, which translates into 2I over 3 with the negative sign in front. I don't like leaving the negative in the denominator. But when there's just an I with a coefficient in the denominator, or just an I, we're just multiplying the top and the bottom by I. When there's a complex number, which is a real and an imaginary number together, now we need to use the conjugate, which is that number with the opposite sign. We're going to FOIL on the bottom. 16 minus 24I plus 24I minus 36I squared. And when I FOIL, if I'm doing it correctly, the middle term should always cancel out. On top, we're just distributing 16 minus 24I. And now, 16 minus 24I over the middle terms cancel. Negative 36 times negative 1 is 36. 36 and 16 is 52. Now, later on, you could see this answer broken up as 16 over 52 minus 24I over 52. I'm not going to make you do that. You may leave your answer as that. And in the final one, same deal. We're multiplying the top and the bottom by 2 minus 7I. The only difference is here is now you got to FOIL the top and the bottom. 6 minus 21I minus 10I plus 35I squared. Don't take shortcuts. That's what runs you into trouble. On the bottom, we have 4 minus 28I. Oh, I'm not sure. Excuse me, not 28I, my fault. 4 minus 14I plus 14I minus 49I squared. Okay. 35 times negative 1 is a negative 35. Negative 35 and 6 is negative 29. Negative 21 minus 10 is a negative 31I. On the bottom, the middle terms cancel. Negative 49 times negative 1 is 49 over plus 4 is 53. And this is our answer.